Hello friends, welcome to my channel. Today I will be discussing about synthetic process for kilogram scale generation of 4-difluoromethylpyridin 2 amine. Here is the chemical structure for this small molecule. This process route was reported in an OPRD journal in 2019. Before going to the process route, I will be discussing few literature reports using several strategies. Like one of the route starts with 4-methyl 2-aminopyridin, where that amine group was protected by using Bock anhydride to get this bis Bock intermediate, which was converted into the gem dibromomethylpyridin intermediate 4 through radical bromination reaction using N-bromosuccinimide and AIBN in carbon tetrachloride. You can notice this step, bromination step, yield is only 10%. That is very poor yield, and exposure of this intermediate 4 to silver nitrate and DMSO led the formation of the aldehyde intermediate 5, which was converted into this difluoromethyl group by using fluorinating reagent, dust reagent. So here is the chemical structure for the dust reagent, and in the final step Bock deprotection was performed using trifluoroacetic acid to get this final molecule. So overall 5 steps reaction and overall yield is 2.8%. You can see almost all the steps reactions yields are good, but because of this second step yield, which is 10%, overall yield drops. So kilogram scale generation of this material using this method is not that much feasible. Now route B, which starts with this 4-difluoromethylpyridin as the starting material, which was converted into the pyridine N oxide using metachloroperbenzoic acid in DCM solvent. You can see the yield is 99%. And at this step, amine group was introduced using this tertiary butyl amine in presence of this 5-prop reagent, phosphoniamylide. So here is the structure of this 5-prop phosphoniamylide. You can see tertiary butyl amine group has been introduced to the next position of this pyridine nitrogen, and that pyridine N oxide again converted back into pyridine moiety. And here in the final step, this removal of this tertiary butyl group was performed by using silane compound. So yields are very good. However, the starting material is quite costly, and also second step you can see reaction was performed under sealed condition, like under pressure condition. So scale up this material using this route was also not that much suitable. So another method that starts with this chlorosubstituted difluoromethylpyridin, where this tertiary butyl carbamate, here is the structure of this tertiary butyl carbamate compound. So it's basically NH2 Bock. So palladium catalyzed Buchwald-Hartwig coupling reaction was performed to introduce this NH Bock group by coupling reaction, and in the final step Bock deprotection was done to get the final molecule. But here also one issue is there, like starting material is quite expensive. It can be synthesized by either of these two processes, like starting from this iodo-chlorosubstituted pyridine and introduction of this difluoromethyl group using copper reagent, and another process is starting from this aldehyde fluorination using the dust reagent. So this overall route includes use of some costly reagents and also hazardous chemicals. So that's why new process was developed. Now I will be discussing that one. So here you can see this method started with this difluoroacetic anhydride as the starting material, which is inexpensive reagent, and reaction of this starting material with this ethyl vinyl ether in presence of pyridine lead to the formation of this enone intermediate. So it's basically nucleophilic attack from this vinyl compound to this carbonyl group of this anhydride, generate this intermediate. This intermediate was not purified. After reaction, it was washed with water to remove excess pyridine, followed by washing with sodium bicarbonate aqueous solution, again washing with brine solution, and then passing through anhydrous sodium sulfate and concentrating the mixture to get the crude material 16. At the same time, another reaction was started, like deprotonation of acetonitrile using butyl lithium in THF solvent to generate this cyanomethyl lithium intermediate 17. So this THF solution of this intermediate 17 was introduced to the solution of this compound 16 in THF solvent at low temperature, like negative 70 degrees Celsius, and intermediate 18 was obtained from this reaction. Here also, after the reaction, so intermediate 18 is a nitrile intermediate. After the reaction completed, reaction was quenched using water, then solvent was removed, and extraction was done using ethyl acetate solvent and dried over sodium sulfate, and activated charcoal and silica gel was added and stirred for 1 hour, filtered, and solvent was evaporated to get this material 3.06 kg. Now this intermediate 18 was treated with this methoxylamine hydrochloride in acetic acid to generate intermediate 19, which was used further without any purification. Now it comes the most important step of this reaction sequence. This is HBr mediated cyclization reaction to get this pyridine intermediate. So you can understand here, this step is very crucial for this conversion. And at the final step, without isolating this intermediate 20, zinc was introduced as the reducing agent for this demethocylation to get the final compound. Now in the final compound, they have treated, after reaction completion, they have treated in some sequence, like I will say, like they filtered the reaction mixture over silite, then solvent was removed by concentration, and it was basified using ammonium hydroxide. Extraction was done using DCM, and then it was passed through anhydrous sodium sulfate, and that solution was treated with activated charcoal, and it was filtered, followed by removal of the solvent to get the crude material, where heptane was added and stirred for 1 hour to precipitate out the material, which was filtered to get the solid material, and the solid was dried to get the desired compound. So in this way, they produced 1.36 kg of this compound, and overall yield for this reaction sequence was 46%. Thank you.